Okay, so for the first one here, what do we have to do first? Where do we start? Yeah, we treat that as 1/4 x plus 1/7 x equals 11. We combine them. Okay, when we add 1/4 and 1/7, what do we get? 11/28. Okay. Then what do we have to do? Divide by 11/28. So x equals 28. How many of you got x equals 28? Good deal. This next one, what's our first step over here? Subtract 6 1/2. So 2/3 x equals 12 1/4. And then we divide by 2/3. X equals 18 3/8, I believe. Any questions on those? How about number 3? Where do we start? We multiply the parentheses by the 3. We get 6x plus 15. Good. Still have the minus 4x equals 21. Then we combine the 6x and negative 4 make 2x plus 15 equals 21. And then subtract 15. 2x equals 6. And then divide by 2 equals 3. Any questions on those? 3. Okay. So one of the toughest concepts in math is to go from words into numbers. Take a situation and put it into something that's usable mathematically. So we're going to start out looking at some phrases and what they imply. For example, if I give you the phrase, a number increased by 7. Now, the number itself could be represented, could be x, could be n, could be y, could be a, could be d, whatever letter you want to use. So we're going to agree for right now that we're just going to use x as that number. So how would we represent a number increased by 7? X plus 7. What are some other phrases that might represent x plus 7? Okay, 7 plus x. 7 plus a number. A number plus 7, there you go. 7 more than a number. Yes, a number plus 7 would work. Any others? The sum of a number and 7. And of course, there are tons of others we could come up with if we wanted to take the time to sit here and go through them. How about this one? Four less than a number. Okay, x minus 4. I get asked all the time, well, how do I know if that's x minus 4 or 4 minus x? Well, if you think about it, let's say you have $4 and your friend has 4 less than you do. They would have 8, right? It'd be $12 minus 4, not 4 minus 12, right? Mm-hmm. So 4 less than means we're subtracting 4 from something. What are some other phrases that might indicate x minus 4? I'll give you one. A number decreased by 4. A number subtract 4. Or you might say subtract 4 from a number. A number reduced by 4. The difference of a number and 4. And again, there's a lot of phrases that we could come up with if we took the time to represent x minus 4, or number minus 4. How about a number repeated 3 times? X times 3 or 3 times x. Normally we just write it as 3x. You're right, without the times in it. 3x means 3 times x. And we usually try to put the number before the variable. What are some other phrases or words that might represent 3x? The number multiplied by 3. Three times a number. Don't really do all the work here, guys. The product of a number and 4. Or the product of 4 and a number. And again, there's several others we could come up with if we took the time to list them out. What's that? The number and 3, I should have said. Yeah. No charge for the extra one. How about a number split 5 ways? X divided by 5. There's actually a couple ways we're going to write this. We write this x divided by 5 or x over 5. And that's most commonly the way we would express it, because that relationship between division and fractions, it's a little bit simpler to have it as x over 5. What are some other phrases that might indicate x over 5 or x divided by 5? Here you go, a number divided by 5. How about quotient of a number and 5? And again, there are several phrases we can come up for that. When it's just a single operation like that, it's not so bad. But it gets more complex when we run into things like this. Seven times the number increased by 4. What's that going to come out to be? 7x plus 4. Good. How about 4 more than 7 times the number? What's that one going to look like? 7x plus 4. Good. Four added to the product of a number and 7. What's that one going to look like? Same thing. The product of a number and 7 is going to be 7 times x. 4 added to that is going to be plus 4. Well, how about this one? What's that one going to look like? Okay. Yeah, up here it was 7 times a number, 7 times a number, which is telling us 7 was multiplying the x. Down here it is 7 times the sum, which is saying we're multiplying the result of the addition problem, which is saying we have to add first to get the sum, x plus 4. So the parentheses are telling us we have to add first, then 7 outside the parentheses. So you have to be a little careful. So what if I give you one like this? Five more than 3 times the number is 17. What's that saying to us? 5 plus 3x or 3x plus 5, either way, right? Equals 17. Very good. Of course, we can solve that for x now. What can we do? Subtract 5. 3x equals 12, and then divide by 3. X equals 4. Sometimes we use pre-existing formulas, like we know that the perimeter of a rectangle is 2 times the length plus 2 times the width. So if I tell you that the length of a rectangle is 9 more than the width, the perimeter is 178. Find the length and the width. Well, I like to draw pictures. Your drawings. And of course we have that formula I'm going to write down. In this formula, I know that P is 178. We gave that in the problem. Perimeter is 178. But I still have 2 variables in it. Do we know how to solve an equation with 2 variables? Not yet, right? So we have to get rid of one of the variables. And the way we do that is we look for a relationship between them. That's given right here. The length of the rectangle is 9 more than the width. So the length, how do we write 9 more than the width? 9 plus W or W plus 9, right? 9 more than the width. So instead of L, I'm going to use W plus 9, and I'll use the W over here. So now 178 equals, instead of 2L, it's going to be 2 times W plus 9 plus then just 2W. So now the only variable we have over there is W. And we can solve. What's going to be our first step? The parentheses should always draw our attention. Nothing to do in the parentheses, so we're going to multiply by the 2 to get 2W plus 18. Good. Equals, then we still have the 2W over there. Now what? We're going to combine the 2W's. 2W and 2W makes 4W. That is a plus there, by the way. Plus 18. Then what? Subtract 18. 160 equals 4W, and then divide by 4. 40 equals W. All done? No. What's wrong yet? We've got to answer the question. Find L and W. So W equals 40. L is W plus 9. So 40 plus 9 makes 49. Now we have answered the question. In your notes, I want you to try this one. The length of a rectangle is 3 times the width. The perimeter is 240. Find the length and the width. Try that one in your notes. We'll come back to that one in a minute. So where'd you start? Length is 3 times the width, right? So L is 3W. So over here, what am I going to do over here? P becomes 240, good, equals 2 times, we replace L with 3W, plus 2W, and then 2 times 3W is 6W, and we still got the plus 2W, and then combine 240 equals 8W, and then divide by 8. 30 equals W. So W equals 30. L equals 3 times 30, or 90. Good. You guys get 30 and 90? Okay. So, our next step, we're going to look at mixtures. I'm going to actually talk about solutions. A solution is made up of 2 parts, a solute and a solvent. Most often, the solute is the active ingredient. Like a lot of medications are solutions. It's a powdered medication, usually dissolved into water, and the solvent is just water. For like a car motor, your coolant, your antifreeze, it's actually ethyl alcohol dissolved in water. So the alcohol is your solute and the water is your solvent. For you guys, if you get to the quenching and heat treating side of it, you don't just quench stuff in water most of the time because it'll make it brittle in many cases. So you might quench it in salt water. So salt would be the solute, the water is still the solvent. Or you might quench them in oil or certain other things. The oil will have additives to it that'll help avoid flaming up. Those additives would be the solute or the active ingredients. You said if you dump it in oil, it helps it from flaming up? Well, there's additives that keep it from flaming if you quench it in oil when it's hot. Have you ever seen a heat treat facility with like oil quenched stainless steel or oil quenched steel period? Yeah. So the amount of that active ingredient, the amount of the solute, is equal to the concentration times the total amount. The concentration is the percent as a decimal. It's what we call a rate. So let's say we have 200 milliliters of a 32% solution. The active ingredient, the amount of the active ingredient, amount of the solute, is equal to the concentration, that's going to be the 32% as a decimal, so 0.32, times the total amount. So I'm going to put that in just parentheses, 200 milliliters. So I'll multiply 0.32 times 200 gives me 64 milliliters. So there's 64 milliliters of that active ingredient in that solution. So let's say we mix 200 milliliters of (71% solution with 300 milliliters of 76% solution. What's the concentration of that mixture when we're done? Well, what we have here is we're combining two ingredients. So we are combining ingredient 1 plus ingredient 2 to get a third ingredient, or a total. That is not an ingredient, it's a total result. And what we're tracking here is the amount of the solute. How much solute is in the first one? Well, it's 71%, so 0.71 times 200. Plus, how much of the solute is in the second one? Yeah, 0.76 times 300. Now we want to know what the concentration is of the third one, so that's going to be X is going to be our concentration. What's the volume of that third one? 500. Where'd that come from? Yeah, we added 200 to 300, we'll get 500. So now we'll take 0.71 times 200 is 142. 0.76 times 300 is 228. You're right. I'm wrong. 228. Then X times 500 is 500X. So then back here, what do? We'll add those together. We get 370 is 500X. And then divided by 500, we get 0.74 equals X. The concentration of 0.74 or 74%. Now, I had a student in one of my other classes ask, can't you just take the percents and average them together? If I averaged 71 and 76, I would get 74.5%. The only way you can average them is if the two amounts are equal. But the amounts aren't equal here.
So if it is a problem with equal...
Yeah, then you just average them would be fine. Yep, it's going to be right between them. More often than not, rather than just mixing two ingredients and figuring out what the concentration is, normally we're shooting for a certain concentration. So let's say we have 120 milliliters of 37% solution. We are going to mix, or we're going to add to that. We're going to add 45% solution to get the concentration to 39%. How much do we need to add? I'm asking how much to add. Well, again, we are mixing two ingredients, 1, 2, and we're getting a total. My first ingredient here is the 37%. So it's 0.37 times 120. What's my second ingredient? 45%, right? So we're going to add 0.45 times, how much of that do we need? X. We don't know how much yet. Equals Do we know the concentration of our result? Yeah, we want it to be 39, right? 0.39. Do we know how much we're going to have? Up here, we just added the 200 and the 300 to get 500, right? So down here, it's going to be 120 plus x, which is 120 plus x, or x plus 120, either way. I'm going to put it in as x plus 120 just because that's simpler for me. So 0.37 times 120. 44.4 plus, this is just 0.45x, equals 0.39x plus 0.39 times 120, 46.8. Now what do we do? We have an x on each side, so we're going to get rid of one of the x's. So we're going to subtract the 0.39x. So it's gone over here. We've got 46.8 is all that's left. Over here we've got the 44.4. 0.45 minus 0.39 is 0.06x. What's next? Let's get rid of one at the 44.4. So we've got 0.06x equals 2.4. And then we have our 0.06. X equals 40. Right, 40? 40 was the amount of the 45%. That's milliliters, yeah, because this is in milliliters. Whatever units the other volume is, what the units of your answer has to be. Well, it's time for me to give you homework. So I'm going to let you try some of these for the next 5 minutes. We'll take our break and we'll come back and talk about more in the second hour. So page 260, exercise 6.5, 1 through 25, the odds. That's translating the words into the symbols. And page 264, exercise 6.6, also 1 through 25, the odds. Tuesday, yeah.